My name is Burak, and Tira and me are gonna run a workshop on Liquid, smart contracts, and taproot maybe. Happy to be here. My name is Burak again. I'm the founder of Arithmetics, which is an AMM on Liquid. Tira and me are contributing to Liquid space as well, and happy to give you guys some sense on how it feels like building on Liquid. So to maybe give some color for those who are not familiar, Liquid is a Bitcoin sidechain. To me, it's more like a layer 2 smart contract platform for Bitcoin. So basically, Liquid is it's based on Elements. Elements is based on Bitcoin core code base, but with things like confidential transactions and native asset support and a sort of additional opcodes. And these opcodes sort of gives you the ability to experiment and play around with some complex smart contract and primitives. Unlike in Bitcoin, which lacks programmability, in Liquid you can build pretty much anything you want. I mean, I have a theory that you can build anything on Liquid that you can do on Ethereum, potentially. The only thing you cannot do is for loops, but with simplicity, I think that is being addressed, so that we should be in a good shape. Today, Liquid has, I think last year we had a bunch of new opcodes bundled with taproot. And then with these opcodes, you can do very efficient and highly complex covenants and smart contracts on Liquid, thanks to introspection opcodes. But prior to that, you could also be able to make contracting primitives with previous opcodes like checksig from stack, cat, substring. I think Liquid may not launch in 2018, and it had checksig from stack and cat. And using that trick, you could do some introspection, but with new opcodes that became even more efficient. So I'll be using Script Wizard ID. This is an online script ID for Bitcoin on Liquid. And on the top right, you can choose your environment. We have Liquid and Bitcoin for SegWit and Taproot. So on the left side, you simply on the left bottom side, right? You type in your script line by line, and on the left top side, you are putting your witness elements that feed your script. And you can see the stack execution line by line on the right side. And at the end of execution, the stack has to end with 1. And I am on Liquid Pay2 witness script hash. This is Taproot version 0. As I told you guys, we had, prior to Taproot, we had some opcodes that were previously disabled on Bitcoin, such as cat. So that you can do some arbitrary data manipulations. I'm right now pushing some arbitrary data, like A, B, B, C, C, and nonsense. I can do just opcat. I can simply concatenate two hex strings, simply. I could also do checksig from stack, and that is not on Bitcoin, and hopefully soon. But since this is a SegWit, this checksig from stack checks ACD, say signature, so let me switch to Liquid Pay to Tablet instead, which checks Schnorr signatures instead. As you see, you can type in any arbitrary string or emojis, and it compiles to the hex representation on the right. And you can do an opcat and do anything, and checksig from stack. But also we had some introspection opcodes. And with these opcodes, you can inspect any part of transaction and apply any arbitrary constraint accordingly. So in order to do that, you have to fill out the transaction template right here. So if you have been to any base 58 bootcamp, I think you should be familiar with this. So in order to use introspection opcodes, you need to fill out the template. So think of this as the spending transaction. You have inputs and outputs. You can add many inputs and outputs. So this radio button over here, when you pick this indicates this input is the covenant input you are spending from. So this is a spending transaction, and this indicates what input you are spending from. And as for outputs, I just want to deal with one input, but you could build very complex constructions, like you can build multiple covenant inputs that interoperate and apply constraints to one another. But for simplicity, let's just keep one input. And for outputs, you can add more and more outputs. Let's say I want 5 Tether. So in Liquid, we have native assets like Tether, Bitcoin, and you can issue your own asset as well on mint.fullpam.com or on your Elements node. Unlike in Bitcoin, right, we have a native asset support, so you could issue shitcoins, whatever. So in this example, so I want my first output, the output index 0, to be tethered, for instance. So in order to do that, I need to fill out this asset ID. So every asset ID on Liquid is represented with 32-byte string. And you can sort of look out for asset IDs on Blockstream Explorer mempool. And I got this Tether USD here. Let me copy the asset ID and paste. So this means that this output carries 5 Tether, right? I'm not filling out the script pipe key, so I'm not interested in this for now because I'm not using any opcodes related to this in this workshop. And as for this second output, let's say I want this output to carry 0.1 Bitcoin. Bitcoin has also an asset ID on Liquid. Obviously, it's a one-on-one peg. And I copy the Bitcoin asset ID for mainnet and paste. So I then hit save, and with that, I can now use introspection opcodes. Let's say I want to inspect the first output, the output index 0 amount, right? In order to do that, I need to first indicate what output index I'm interested in, and then I need to type in inspect output value. So what this opcode does, hence the name, it inspects the output value, right? The first output index. I could have just typed in 0 or op0. This compiles to op0. If I wanted to inspect first output, then I should have typed 1, but it's 0. What this does is essentially it consumes one input, and then it inspects the respective output index and pushes the amount, the inspected amount, and 1. And this 1 indicates this is an explicit value. Because in Liquid we have confidential transactions, and that is opt-in. You can opt in and out. An output can be confidential or non-confidential. In this case, this output, the two outputs here are non-confidential. We're not opting into confidential transactions here. So the asset ID and asset amounts are explicit. In Liquid, script pipe keys are always public. So they're not blinded. So this one indicates this is an explicit value. If this otherwise was a confidential output, this should have pushed 0 and a 32-byte value commitment. But in this case, this is confidential, so I want to make sure this is explicit by doing elk verify. And then it leaves stack with our 8-byte amount field. In Liquid, amounts are the amount fields are big endian as opposed to Bitcoin in little endian. But this is big endian 8-byte amount pushed onto stack. That is 500 million units, right? This is tethered, but it also has 100 million units. So I can just do, let's say I want to constrain this output to 5 in my script. And in that case, I need to type in 500 million. But this is a script number, right? But I have to cast this into a 64-bit little big endian. Actually, this is little endian, I guess. They're big endian, but it pushes onto stack the little endian representation. So I have to cast script number to little endian. What this does is this casts this 4-byte script num into 8-byte little endian, and I can just do op equal to constrain that. This is a very primitive covenant. You can constrain. I just constrain the first output to 5 tether units. And I could have just hard-coded this value in my script as well. That could also work, or even in the witness field. It's up to your use case. And same goes for values, sort of amount, the asset IDs. I could have just done inspect output asset, and that consumes 0, right? 0 in output index. 1 in case this is an explicit asset ID. If this was otherwise a confidential asset, this should have been 0, and this should have been a 32 byte asset commitment. And I verified this, I double checked this is an explicit asset ID, and I can simply constrain this to a tether asset ID, simply, or just put in witness. That could also work. And same goes for the first output, so the second output. If I go higher, I'll get an error because I only have 2 outputs in my template. You could also import real transaction templates, like real transactions, and that fills automatically with real transactions, both on Bitcoin and Liquid and mainnet and testnet. You can inspect pretty much any field, like TX version, time log, strip pub keys, even like number of inputs. Yeah, num of inputs, num outputs, pretty much, and current input index, and so on. We also have 64-bit arithmetics. You can multiply and divide and add, subtract 64-bit arithmetics. Let's say I want to multiply 5 with 10, but I have to first cast this into a little 64-bit little endian again, using script num to little endian. And then let's push 10 in little endian, and I can just do opmal 64. This one indicates this is not overflow. If it overflow, it pushes operands plus 0. And I have to double check this is not an overflow behavior. And this, here comes the result, 50. And you can do division, addition, subtraction. So once you're done with your script, you can actually, let me put this in witness and do an op equal. Yeah, so this script succeeds. As you see, it ends with 1. So once you're done with your script, you can go to compile button, compile your script. This compiles your script into bytecode and to a taproot output. So this is a taproot script, right? A Tapscript, and this is a V1 taproot output. In order to font this, first of all, you can indicate a key path spent. We don't typically we typically don't want key path spent, so you could fill with a discrete logarithm, a non-discrete logarithm, so that there is no possible key path spent. It's script path spent only. And you can indicate tablet version, but it's C4 by default. And then it gives you the mainnet and testnet addresses that you can fund. So you can just copy and fund it with your node. The tricky part is spending, right? Constructing script and funding is the easiest part with the ID, but spending is really tricky. Like I don't know, I can't think of any easy solution to that. Maybe we should build out a transaction builder on with Marina integrated. Yeah, maybe, because the way we do this right now, we just manually build construct transactions by hand in hex and spend it. Like you have to place witness elements in literally the witness script in the witness field, and construct the outpoints and outputs and broadcast the transaction. That's how it works. That's how we are working with this. But yeah, we could maybe look for an easy solution to that. And also we have some built-in tools for you that you might find useful. We have signature tools right accessible right here on the browser, but we don't have an internet connection, sadly. So you can do, we have ECD essential tools for verifying and generating signatures, and a MAST tool and some data manipulation tools you can check out. I think that pretty much sums up everything in my workshop, and I'll leave it to Marco. So this is a very low level way of building things. I know the entry barrier you may find is very high, but we are working on lowering the entry barrier with building. We're working on, and Marco is working on a high level smart contracting language with a JavaScript-like syntax, right? It's called Ionia.
Yeah, it will be Ivy fork. If people remembers in Bitcoin there is this Ivy smart contract language, so we are like adapting this syntax also for Liquid, but not only Liquid I would say, but specifically simplicity. So ideally, whatever elements virtual machine, which is basically the combination of all the opcodes plus the elements blockchain, we can replicate that in simplicity. So simplicity should come end of the year, paging blocks 10 people here. So eventually with this language that I'm going, maybe I can just proceed on the workshop. It's called Ionio. So basically, as I said, it's an ID superset which supports for now Liquid, but eventually simplicity. So let me connect. So.
Sorry, real fast. Burak, you said for ScriptWiz is that you're doing the constructions, you're constructing at the byte level, and so for the transactions for spending out of it, it's like when I'm constructing the script and it's evaluated to true, is that I can't export like when I want to spend out of this thing, this is what the witness is going to be for that. I can't export that right now?
Oh, right now, no. I think we should work on that indeed, but you can simply, yeah, because it could be a bit tricky for now because you have to. You see the stack elements we compile on the right side, but they are var int, so you have to add the length prefix. That'd be tricky. Yeah. So we have to work on that.
So okay, unfortunately I don't have internet. I don't know, I cannot present and having internet at the same time, so it's a bummer. But anyway, you can check it out, ionio-lang.org. Basically, there is no language already yet because we are working on. But what we decided is to start backwards and to start with an SDK for developer. Out of time, writing the script or writing the contract is not that the hard part, in my opinion. Yes, it's like not the easiest way to just work code by code, but I guess Script Wizard helping a lot in debugging. But once you have your script, that's as Burak said, it's very hard. How to spend it, how your wallet, how other application can understand this contract and understand how to track balances, how to spend all the possible Tapscript leaf, right? So, and I think that we're starting now with Ionio SDK. Ionio SDK, I want to share the documentation, but I can't actually. If you go to artifact, so just imagine, if you go to the artifact section of the documentation, there is this concept we introduced, which is what is an artifact. It's literally a JSON file that describes giving your low-level bytecode. Now is like Bitcoin script of codes. In the future will be simplicity programs. Literally can describe for other libraries, other SDK, other wallet, can describe how this contract works, which means which constructor input you need. So think about before Burak shared with you, he was coding some parameter, right, in the contract. Like for example, I expect to have 5 tether on this output. This is a constructor input. So this artifact will basically analyze your opcodes and say, okay, there are these parameter for the contract and the types for each parameter. So number, bytes, value, and asset that are like semantically, are bytes, but they are semantically types. And beside that, we have also, sorry guys. So basically, once you have done your own contracts, right, with ScriptWiz by hand or maybe in the future a language, you will basically compile and create this JSON file, which the purpose of this artifact is that any language can understand this file and can implement SDK for any other language. So very quick, as I was saying, we have a contract name, then we have an array, which is a constructor inputs. So for example, in a transfer with time block, which is a very basic construction, you may want to encode in your contract the delay, and so we can give a name, a numerical name, and a type, which is now number of blocks, and a pub key maybe, right? So it's a XOLI pub key, so it's schnorr check sig. Then you have your functions, and function is literally each function binds to a Tapscript leaf in the end contract. And again, you can have a enumeratable name for your function, like it can be a transfer, for example, and an array of function inputs. When you have a check sig operation, automatically you will have also an input, which is a signature, and a type sig. Then the interesting part that at the moment is not covered by other, I would say other solution like Miniscript or Output Descriptor is how I can tell to other libraries, the other wallet, hey, this contract has some requirements. Let's call covenants. So we call it required. So it, again, is another array that will tell me what type of requirements this contract has, and we kind of put the time blocks as sort of requirement because we think that both time blocks that we already have on Bitcoin and also covenants on output on input that Burak shows to us, in my opinion and in general opinion, they are kind of covenants because they are not something that the user is providing, but is something that the context is important. So for the time block, the blockchain should be 1, 2 block, 3, 4 block ahead, and for introspection outputs and inputs, it's something that you need to provide. When you're going to spend this address, you need to spend it in a transaction that is done in the way the requirements dictates. Then you have your assembly, ASM, and this is basically what Burak was writing hands by hands. One interesting thing we added is templating strings. So basically you can use $sign and then put whatever human readable name, and this, if you can see, this delay or this pub key will basically be replaced when the contract is compiled by the constructor input. So basically SDKs can say, okay, give me an array of constructor inputs, give me your function parameter, and this is technically the witness stack, right? And I can replace it in your contract automatically, right? Because you specify to me these template strings. Okay, this is just the theoretical part, so let's go writing our first interaction with contract. So let me go back to, okay, I don't have internet. HDMI cable was too hard, right? Okay. So if you go on the first, okay, back here. Uh, 176. Okay. So if you're going on the blog post, on the blog section, you will have the tutorial you can follow now if you have your own computer, if you want to follow. There are some requirements. One is having Docker and Node.js because the first SDK is using JavaScript, but again, with this artifact JSON, every language can be used because the JSON is the de facto standard, so any language can any SDK, and we will build SDK for every language, but we are starting with that mostly for browser and having some interaction. So we are going to do a very basic calculator, right? So when you do a new language or you learn a new language, the first thing you do usually is a calculator. Does it make sense for Bitcoin or script? No, but just to show the paradigm of this artifact JSON. So yeah, there is some context again. There is some alternatives like output descriptor and miniscript. One thing I want to mention is the fact that output descriptor and miniscript, they are for humans. Shows engineering readable, but again, it's for humans. But when I want to share between libraries, wallets, I need something machine can easily understand. For sure, I can write my parser for miniscript and descriptor. We have done that. But writing a parser for every language is not easy. JSON is literally the best way to transport your content. Miniscript does other things like static analysis. This JSON is only a transport for your own metadata to give to your wallet, and the wallet can track your balances and can spend. So okay, I'm going to start. Of course, if any problem, please stop me. It's like very hands-on, like step by step. If you have already this environment, which is having Docker and Docker Compose, and Nigiri, which is just one click, it will spin up for you a Bitcoin node, a Liquid node, Explorer, front-end, back-end, and some tooling, for automatic mining and other stuff. So I assume this is. I don't want to, install again because I need to switch off. So just assume this works. Maybe you can follow and you can switch to testnet. So if you want to try directly with testnet, so I just assuming. Okay, let me start. Okay. Maybe I already have Nigiri running, so let me switch it off and start again. Yes, I was. Anyway, if you already have your own reg test or whatever, I'm just running a reg test, blockchain for Liquid plus, Explorer and other stuff. If I go to localhost 5001, we can check the Explorer. Give us a couple of seconds. Okay, so basically we have a clean reg test blockchain right here for Liquid. So let's go ahead with the tutorial. So first thing I will do, I'm using this template, which is just a JavaScript web app, and this JavaScript web app will just interact with the contract and will do all the stuff like understanding this artifact and passing all the parameter to try to spend our calculator. So I'm just making this to download this Svelte Webpack template I have here. Tell me if it's too small. Maybe I can zoom it out a bit.
Yeah, it's better.
Yeah. Okay, no, I've done something wrong. Again, I don't have internet. So just trust me what I'm following beside me while I'm just downloading all the dependencies. So I'm done in the first step, pull template, install dependencies. Hopefully after this there is no need of internet anymore. Yes, should be. So I'm making sure my application can load JSONs, so we just need this. Okay, so let's take this artifact JSON, which is basically our calculator we saw before. So we have just one function, which is sum must be 3, okay? Then we have one constructor input, which is the sum, we will pass dynamically. And then this function accepts two parameters, so A and B. There are two numbers and no requirements, so we don't have any time lock or any covenants or something else. And the script is very easy. So just we have an opad, then we want to have here replace the constructor input, which is the sum, and then verify, that the sum is correct. So the two parameters we are passing correspond to the sum. So very easy. So I'm copying this and I'm putting here in my application. So I have my JSON here. Let's add some layout, of our HTML page. So just to make it look something. So nothing to see here. I want to add some state to my web application over here in this script. So very, very easy. I'm just importing Ionio SDK here. Let me zoom a bit. I'm importing Ionio SDK, the contract, abstraction. Then we're importing something from LiquidJS. If you already work with JavaScript in Bitcoin, you maybe have used Bitcoin JS, and LiquidJS is the fork. And then I have this Rust, SecP library to do other stuff, and then I'm importing my calculator JSON. I'm defining regtest as the network we're working on, the state of our transaction, the final transaction we're going to broadcast, so let's put it empty for now. And then I'm defining that I want to do, to lock 100k Satoshi, and the fee will be 100 sats, just to keep it hard-coded for now, for our contract. So this is basically 99% of Ionio SDK. So basically I will, if you can see, in our contract, I pass my JSON file, so this instance can understand himself and do his own stuff. Then I'm passing my constructor. As we saw before, in the constructor we only want the sum, which must be 3. So I'm passing the 3 as a number here. And then some network and the SecP library, so we can inject our own library if we want to use something else outside the browser or whatever. And that's it. So then we can get from this contract variable the address. So basically this Ionio SDK is getting the JSON, understanding, replacing the constructor input with the templating strings, and compile the script. If I run this, it should be able to see if I didn't forget something. Okay. So we can go here. Okay, we have our calculator, very, very easy. So this address basically is encoding whatever we pass in the constructor input. Is a taproot output, so we cannot see, actually we cannot decode and see the codes because they are hidden inside a leaf. Of course, if taproot is not well known, please stop me or just ask me, but I'm just assuming that taproot works in the same way as Bitcoin. So if we go in our Explorer, we started, our regtest instance. We can check here, this address is empty, so we need to fund it, right? So what we are going to do is to fund it with Nigiri. Nigiri, beside just spinning up your own nodes and Explorer, adds also some useful tool like faucet, minting an asset on Liquid, or automatically mine any transaction when you push it to the Explorer. So I'm going to fund this address. So let's replace the address our app is showing. And 100k sats. Okay, so it automatically mined transaction, Nigiri for us, so we got one confirmation. We can see now we just need to take notes about the VOUT and the transaction ID. So the index of the output that is funded now I can see is 1. And this is basically maybe details will give me some more details, like for example here, is a version 1 pay to taproot output. And this is basically, like our codes, and this is the MAST, Merkle tree that we are like adding in the contract. Everything is confidential, so we can see, that we funded, 100k satoshis, and this is the asset ID for regtest of Bitcoin. So okay, we funded our contract. Now we need to spend it, right? So that's the hard part that, as Burak was saying. And this Ionio literally like helps us in everything, and Ionio exposes us a couple of functions. So let's say that once I create a touch to a real life instance, so basically I need to pass the transaction ID that when we found it, the vout and the prevout. But this is just a way for the contract to say, hey, I exist in the blockchain, right? So I would say, let's call it, elements virtual machine, I exist. So there is some deployment there, right? So there is some contract of this template being deployed there. So I want Ionio to know about this. Once we get our instance attached, so we understand this, then we can call what we saw before. If you remember, we called the function sum must be 3. So Ionio automatically generates all the possible function name. So if I want to spend this specific Tapscript leaf, it will have this UMA readable name to be passed. And then I add my function inputs. And I want now to succeed this contract, so I want to get these funds out. So I'm passing something that, the sum is 3, so I'm passing 1, 2. Then there are some convenience function also, so I can attach some recipient in this transaction, the fee output and the stuff. This is useful when you do introspection of codes. So because Ionio will also validate for you, hey, you are going to spend a transaction without the output at index 0, and the artifact is telling me that you need that requirement. So this is just a convenience. So I'm just copying this code and attaching to the button, over the button. So I guess I can do here. We have our on-click function. Oh, okay, I need to import some LiquidJS thing. Confidential and classification. Eventually, if you already have your own script to get the prevout of a UTXO, maybe you can just get from the raw transaction, but for me it was easier to do like this. There can be another way. So, okay, I'm passing 1, 2, and basically this unlock will do all the magic. Basically we'll construct the control block and the script leaf, and we'll also do all the verification based on the artifacts, and this will finalize the transaction. Finalize is important because we need to pass this witness, these parent function inputs that are basically witness stack, right? So things that I need to put on the stack to be able to spend. There is no signature here. I don't need to do any signature here because it's just simply, I just need to provide these 2 inputs, which is 2 numbers. And then if the script works, you can spend it. So okay, we can expose a PSBT interface as well. So then we can extract the transaction and make the raw X. So we can do one last thing, I guess. Okay, I need to attach this on-click button. This on-click function to this button, and theoretically I should be okay. Let me check if I've done everything correctly. Okay, so we can do this. So let me get an address where we want to unlock the funds as sent to. So Nigiri does this, so I can just get a new address out of my node. So okay. Here should be already compiled. So if you go here, okay, the transaction hash of before that when we funded was this. So transaction hash, so you can attach to this real life contract. The vout was like 1, yeah, 1, and then the recipient. Of course, now I'm doing this UI, but you can do whatever you want later. Okay, let me check. Maybe I've done something I forgot. Okay, give me 1 second. Let me something. I need the internet maybe. So, 1 second.
When you're making that human readable function off of the contract, you're just passing. You can only pass data fields into there, right? Because you're just assembling the witness stack, and you have to do that in order, right? For the witness stack. So if I'm doing like signature, so if I'm like if I want to do the signature for it, right? So,
Oh, yeah.
it has to be hub key. Then like the witness stack has to look like signature hub key, right? Like
Yes.
in order.
So the idea of the SDK is that you need to pass me a signer interface. So
Yeah.
when there is a signature, you can do a ledger, you can do your own hardware wallet. So you don't
Yeah.
need to pass manually the signature on the
Okay,
stack.
gotcha.
So we do that for you. We understand that that is a SIG type,
Yeah.
and then we attach it.
Okay, awesome.
Okay, let me refund it since I already spent it and I wasn't sharing. So let me refund it again so we can force it. So 100k sats. Yeah, this should be the latest one. Yeah. So Walt 0 and this is the transaction hash. So okay, I go here, type the transaction hash so I can attach it. Let me get again elements address of someone else. So basically, Ion SDK does all the magic here. So finalize, takes all the things and so on. So we can go here and broadcast. So we broadcasted our transaction, and this was the original input, right, with 100k sats. And basically, I added the recipient there. And if we go check the witness, basically I'm passing 01, 02, and this should be, if I'm not wrong, this should be the script X.
All
Yeah,
that's three
yeah.
equal.
Should be the exactly. So this is basically opcodes, encoded as X, and this is the control block, the final control block that you need to spend when you spend the taproot output. And that's it. So this is basically a calculator. I mean, seems like too much stuff, but literally, if we go back and see the fact that we can, with one line, get a JSON and understand all this kind of stuff, replace the stuff. This allow to create literally like all possible contract and to load them at runtime. So wallets can load at runtime this, understand this, and and show you an address. And the second part which helps is especially spending. So this unlock function is literally doing the magic here, which is doing whatever you need, because with taproot is really, it's harder to spend a taproot output than a normal one because you need to reconstruct the control block, you need the tree, the full tree. So that's why having the JSON, this SDK can be stateless. So basically this SDK can every time recompute the taproot tree and understand how to replace the constructor input and so on. That's it. Of course, we have some other more advanced example. If we go, for example, there was the single hop vault that was very famous with CTV, and we can definitely do it. Let me see. I don't know if we have time because
I think you guys got like 10 minutes.
we have 10 minutes.
Yeah, thanks.
Okay. So if we have 10 minutes. So we can try also something, like a covenant, like to spend it. It is in examples in the Ionio repository. So same thing. Let me close this up. Let me run this. Okay, I'm clean. So if I go here. Okay, so this was another an example. So this is basically the vault, and if you can go see, I need to switch again internet, but you can find the JSON, or maybe I have here, 1 second. I can show it from the code. Yeah, I can show it from here. Artifacts. So basically, if we want to write, of course, this JSON should not be write by hand, in my opinion. So like either Ionian, when we came out with the high-level contract smart contract language, we will compile. Also, there is a fork called scriptwiz, so you write your opcodes and then you compile, and then it will give you this JSON, because everything can be like analyzed statically, so we can understand this. So if we go analyze a bit what we need for a single op vault, it's like, give me your, if people are not familiar with the idea, basically is that you can send right away to a cold address, so something that you control right away, or another path will be after a delay, you can send to an hot wallet, right? So this is idea of non-recursive covenant, non-recursive vault. So basically, as a constructor input, we want to our code in our script is like, give me your code script program, right? Because I just want the program, I don't want like the prefix, the SegWit prefix, and so on. Give me the amount you want to encumber by this covenant, the asset hash you want to encumber, and the delay for the hot path span. So our first function is called sweep, and no inputs, right? Because there is no signature. We just want to say, hey, anybody can spend this, as long you are sending to this specific output at index 0, and we expect the script to be version 0 and cold script program, right? This is basically SegWit, pay to pub key hash witness, right? So this is version 0 and the program, and then the value, we want to replace it. Again, this is templated string. Templated strings also work in requirements, and so you encumber the value in the asset hash, and the nonce can be, nonce is a liquid thing, you can not care for now. And this is our opcode leads, this ASM assembly. So as Burak showed before, basically we are saying op0, give me your script pub key, and verify is equal to cold script program, verify is equal to the amount, verify also that is equal to asset hash, and okay, we are checking the nonce, but makes no sense to check it again. And this is the first function. This is a code sweep, so no signature, just is forced to send to that specific cold address. And then we have the delayed hot span, and again no inputs, but we have another more requirement, not only output, but we also have older. This is a type of requirement, right? Which is basically check sequence verify, and so you can encumber with the delay. That's it. So if we try to compile, and we hope works. So this address, if I go to the blockchain, should be like clean, right? So let me find it. Okay, I guess 0.01 is fine, like 100k sats. Let me check the code to be sure that I'm putting the right parameters. So yeah, 100k sats, fee 100, and yeah, there are these addresses. So this is the hot address, this is the cold address I want to encumber. And again, I'm opening a new contract. I'm passing now much more like constructor argument now, so the cold script program, the amount you want to encumber, so it's Satoshi fee, and network asset hash, and 2, I guess, is the number of blocks. So this hot path span can be spent after 2 blocks. And the same thing we have done now, right? So if we try to spend the code, okay, let's take this transaction hash we just funded. I guess without the index is 0. Okay, so, and we didn't specify the recipient because again, the covenants inside the contract is like forcing this transaction to go to that specific address. So if we try to broadcast, hopefully it works. Okay, it worked. So as you can see here, this was our vault that now was unbolted, to this with normal SegWit address that we are coded there. And of course, if I change the address here, it will not work. Like the blockchain will refuse that. If we try to do the hot span instead, I need to fund it again because I spend it, of course. So let's fund it again. So I'm reusing address here, of course. And if you put, of course, more complex contract with pub key, that will change every time you derive a new pub key. So let me fund it again. Address will be the same. Okay. So we funded. Was here. be this, right? Yes. The out here is 1. Hot span. No, didn't copy the transaction. Of course, this can be automated again with a wallet. He knows about the UTXO and so on, so it can be automated.
Yeah.
So if I try to broadcast this, will not work, of course, right? Because this is the hot path, the delayed hot span. So first will tell us something.
You picked the wrong
This
word.
will be,
You should have said 1 word. You entered 0.
Oh, okay. Sorry, let's do it again. Should be a different error, like beep 68 error, whatever. So it wasn't this. No. Let me check again. So it should be this, right? And the route you said is like the 1. Okay, I picked the wrong one. 1. Okay, it should be updated. Okay, so lock time is not satisfied, right? And this is basically what prevents us, to send to our hot address, and this is by design. I guess that Nigiri, whenever we push to the Explorer, we intercept that and we mine a block, if I remember correctly. So yeah, we mine a block. So let's try to broadcast again the same one. Okay, so 2 blocks, right? So the third should work. Oh, third block. Okay, I don't know why, but yeah, we'll check. Anyway, the gist is basically this, right? So this Ion SDK, of course, now works for Liquid because it makes it interesting because we have covenants. But the idea of Ion to be a simplicity smart contract language. So eventually simplicity will literally be the best version of Bitcoin script, and we can replicate whatever we can do now in the elements script. We can replicate that in simplicity and do even much more. So we be stalled on the IV fork, for Liquid because we think simplicity makes more sense. But meanwhile, we started with this SDK, and definitely if you already write your own opcodes by hand, which in the end is not that hard, then eventually ScriptWiz will add a way to compile this artifact JSON, and then you can create with this SDK now in the browser, but even other language, you can easily interact with your contract. So I guess cool. We're done.
Nice.
Thank you guys.
Thank you.